Hello, everyone. Today we're going to go over this paper. It's called Hospital Admission and Emergency Care Attendance Risk for SARS-CoV-2 Delta Compared with Alpha Variants of Concern, a cohort study. All right, so this is a study out of the United Kingdom, and they're comparing the Delta variant to the Alpha variant. The Alpha variant was previously called the UK variant, and that's the variant that was more transmissible than the wild type, but didn't seem to be that much more dangerous and had pretty good vaccine coverage. So wasn't too different than the wild type, other than that it was more transmissible. And I have videos about what the exact amino acid mutations were with the alpha variant and the delta variant. If you want to, you can find those linked below. Okay, so let's go over the summary or the abstract. All right, so they're saying that it was first detected in England in March, and it rapidly become the predominant lineage. So it's the most common type of variant that's found now. So what's important to know is that when people get tested for COVID, they don't know which variant they have. The only way to know which variant you have is to get the entire virus sequenced, and not everyone that gets diagnosed gets sequenced. So in America and in the UK, and the UK does a little bit better job of this, they will randomly sequence some of the viruses from some of the people to kind of get a sample and to decide what's becoming the more prevalent virus. So anyways, they know that it's now the predominant lineage in the UK, also the predominant lineage in the United States, and probably around most of the world. Okay, this cohort study was done amongst all patients with COVID-19 between March and May of 2021 who were identified as being infected with either the alpha or the delta SARS through whole genome sequencing. So they sequenced the entire virus. Individual level data on these patients were linked to routine healthcare data sets on vaccination, emergency care attendance, and hospital admissions and mortality. Okay, so they found out all the people that had their virus sequenced, and they knew that they had either alpha or delta, and they looked at information on whether or not the person was vaccinated. Did they go to the emergency room? Were they admitted to the hospital? And did they die? The risk for hospital admission and emergency care attendance were compared between the patients with sequence-confirmed delta and alpha variants for the whole cohort and by vaccination status subgroups. All right, so then they adjusted for variables like age, sex, ethnicity, deprivation, recent international travel, areas of residence, calendar week, and vaccination status. So they try to adjust for those things that vary between the two groups. So that, like if one group had like way older people, obviously they're going to get admitted to the hospital more often. So they try to adjust for other factors that might interfere with that, other than it being delta or alpha. All right, so they found individual level data on about 40,000 people. 9,000 had delta, and 34,000 had alpha. And that's because this was during the middle of the transition between alpha being the dominant to delta being the dominant. If they did this study probably from May until now, you'd be mostly delta and less alpha. Median age was 31. Okay, and so about 2.3% of the patients with delta versus 2.2% of patients with alpha were admitted to the hospital within 14 days after the specimen was taken. Well, that seems weird. How are they getting a hazard ratio of 2.2 when the percentages are about the same? Okay, well, let's keep reading. Maybe we can figure this out. Then 5.7% of the patients with delta versus 4.7% of the patients were admitted to the hospital or attended emergency care within 14 days. Okay, yeah, so that seems a little higher, but I don't know why they get the hazard ratio of 1.45. That means, if you look at this hazard ratio, it looks like they're 45% more likely to get admitted or go to the emergency room if they have delta. And this hazard ratio is like 126% more likely, or 2.2 times more likely. Most of the patients were unvaccinated across both groups. Okay, so both in the alpha and the delta, the majority were unvaccinated, so 74%. The hazard ratios for the vaccinated patients, 1.94, were the same as for unvaccinated patients. So what that means is according to this paper, if you got the virus, you were more likely, I mean, you were equally likely to go to the hospital if you were vaccinated or unvaccinated. But the majority of them were unvaccinated, of the people that got the virus. Now, what we don't know is we don't know the denominator here. I don't. Maybe they'll tell us in the conclusions, but we don't know the denominator. Like, what percentage in the population were unvaccinated? I believe UK had a because if most of the people in the UK were unvaccinated, well, it would make sense that most of the people who got it were unvaccinated. But if most of the people in the UK were vaccinated and the majority of the people who got the virus were unvaccinated, that would mean that the vaccination was conferring some kind of protection on the vaccinated group. So you can't interpret this data that the majority were unvaccinated as meaning necessarily that that the unvaccinated were getting it more often. It depends on the denominator, how many people in the population were unvaccinated. But I believe that most of the population in England were vaccinated. Okay. So that's interesting. What they're saying is that you are 2 times more likely to be hospitalized if you get Delta than Alpha, which would suggest that Delta is a more dangerous virus, which until fairly recently, we were thinking that Delta was just more transmissible, so it had a high R naught value, so it's more transmissible, but it wasn't necessarily more dangerous. But this paper suggests that it is. Now, what I don't understand is how they're getting this 2.3% of the patients were admitted to the hospital. That doesn't even make sense. 200. But they're saying that it's a hazard ratio of 2 because this percentage should be twice as high as this percentage to get this hazard ratio. Okay, well, anyways, take home, their conclusion is that basically Delta is twice as dangerous in terms of getting admitted to the hospital. And if you just wanted the cliff notes of the paper, we're done. I'm going to delve into the methods and kind of try to critically analyze it if you want to stick with the rest of the video. Okay, let's go to the methods. So this is like if you want to decide whether you believe a paper or not, you want to go into the methods and see if the methods seem reasonable for what they did. Like if you were going to decide what's better, how would you do it? And so the ideal situation is that you would know everyone in the whole country that got Delta versus Alpha and know who got admitted and who didn't, and make sure that they had the same kind of premorbid conditions, obesity, age, pre-existing conditions, that those were all the same. Now, obviously, you can't do that. You can't figure out everyone. So they got a sample, and every research paper is a sample size. So they got a sample, and it looks like they looked at everyone that got a genome level sequencing. And that was 40,000 people, which is a big number. Okay, these are the covariants and co-founders. So they looked at age, sex, area of residence. I don't know why area of residence was important. Maybe some areas are poorer or richer, and so that generally socioeconomic class does correlate with health outcomes because of access to care and stuff. Although that should be less of an issue in the UK, where they have kind of free access to care for everyone. They looked at recent travel. I'm not sure why that was important. Yeah, so lower tier local authority areas, ethnicity, age. So age obviously makes a difference. I don't know why when they got the specimen makes a difference. Socioeconomic deprivation, yes, because that, again, like we said, socioeconomic class does tend to correlate with health outcomes. All right, statistical analysis. I have no expertise in determining whether they did appropriate statistical analysis or not, so I'll just assume that they did. Okay, so we're back. These are the results. So they found 50,000 that had sequence confirmed cases. They excluded about 6,000 of them because they were missing their NHS numbers or their medical record numbers. All right. So they show that over time, the alpha variant used to be 99% of all the cases back in March and decreased to 34% by May. So the switchover had already happened. By May, most of them were Delta. Patients with the Delta variant were younger. So that doesn't necessarily mean that Delta preferentially attacks younger people. There could be several reasons for that. One could be that all the older people had gotten more vaccinated, so there were less of the susceptible people to get the Delta variant. The other reason it could be that the older people had already gotten, more susceptible people had already gotten the Alpha variant, and they had a little bit of immunity and were less likely to get the Delta. There's several other reasons. I can't, we can think of several more if we sat here and thought about it more. But you can't just take all this stuff at face value. Okay, so here we go. Let's look at the tables. All right, this is just their basically their cohort analysis. So age, you can see that the Delta group skews younger, so higher percentages in the younger age groups and lower percentage in the higher age groups. So yeah, it skews younger. In terms of male, female, it seems relatively the same. You could say that Delta skews a little bit more male, but I bet that's not statistically significant. In terms of ethnicity, there seems to be a huge disparity here, actually. I don't know if they mention it, but the Delta seems to affect Asians much more than white people. And that's interesting. And there does seem to be a skew in the region of residence. That kind of makes sense because the variants are going to spread regionally. So I don't think that has anything to do with the biology. That has probably more to do with like the population spread of the thing. I'm not too sure what this multiple deprivation standard is. I think it probably has to do with the socioeconomic class, and I don't know if 1 or 5 is worse, but it seems to track across, so this doesn't seem to be a big confounder in terms of who gets infected. Vaccination status. So most of them are unvaccinated. Recent international travel doesn't seem to matter. And about half of them were asymptomatic at the time of, but they must be doing just routine sampling of asymptomatic people in the UK, which is interesting. Okay, so hospitalization outcomes. Okay. So here's the answer to our study, our question from the thing. So basically, they're saying based on hospital admissions, there was 2.2% of alpha variant people were hospitalized, and 2.3% of the delta variant were hospitalized. However, because the delta variant skewed younger, and they stratified for ethnicity. When they stratified it, when they adjust it for all these covariates, then what happens is that it is 2.26% more likely. Yeah. So after adjusting for it. So when you look at it straight on, it's about the same, which is why I was confused in the abstract. Why are the percentages pretty much the same? And they were saying the hazard ratio was twice as bad. It's only after you adjust for age, gender, socioeconomic class, and that kind of stuff that it turns into this. Now that's pretty important because then I can't really assess how much I believe this study because it depends on what kind of statistical analysis they did. Let's go to it. Okay, they use Cox regression analysis, so that's a pretty standard regression analysis. This is the secondary analysis. Okay, yeah, the proportional hazards assumption. So yeah, like I don't know enough about statistics to say if this is the appropriate test to use. Using Schoenfeld residual plots. So I guess I'll have to assume that that's correct and that they know what they're doing. It was peer reviewed, so this is not a preprint. It means someone has reviewed this, and usually it's they always have a statistician review these things that are heavy in statistics. So a statistician reviewed this paper and decided that they had used the correct statistical test. So I think we have to believe that this is reasonable. So unless we have a specific reason to believe that that's not true, this hazard ratio is probably true, and that delta is twice as likely to get you admitted to the hospital than alpha. So in unvaccinated people, you are twice as likely to get admitted to the hospital with delta. And then in people who've had at least their first vaccine, you're a little under 2. So it's not too much of a difference. As you can see here, p-value is 0.8, which means it's not significant. So whether you're vaccinated or unvaccinated, you seem to have the same risk of getting hospitalized with delta, according to this study, which goes against some of the other papers which say that that vaccination protects you from hospitalization. So maybe what it is that it protects you from hospitalization across all variants, but there's no difference between the alpha and the delta. Okay, all right. All right, let's see what they say in their discussion. So this is my first time reading through this paper, so yeah, so this is a big problem for them. There's no available data on comorbidities. So they try to use like gender and age as a proxy for that. But it would have been much better if they had the comorbidities, like did they have diabetes? Are they obese? Do they have pulmonary disease? Do they have kidney disease? Do they have heart disease? Those would have been much better than yeah. So this study instead indirectly accounted for comorbidities using related covariants, including age, sex, ethnicity, and deprivation. So this is not in that way, this is not a great study. Like if they had, but that's the best they could do with the data they had. So they knew they need to adjust between the two groups somehow, and this is the information they had, so this is the information they used. But if they could get direct comorbidities, that would have been much better. So, okay. Okay. All right. So interesting study. I think that based on a kind of an imperfect data set, but a large data set, and they did try to account for comorbidities, which I think they did a reasonable job of it. I mean, using deprivation, so income, because a lot of comorbidities do track with socioeconomic class. So it's a reasonable way of adjusting for that. What they do find is that the delta is twice as likely, generally twice as likely, to get you admitted to the hospital than with the alpha, and that vaccinated people and unvaccinated people are both equally as likely from alpha to delta to get admitted to the hospital. What it doesn't tell you is, does vaccination protect you from getting admitted to the hospital? This study was not designed to do that. It's just designed to check between the two. If they wanted to check whether or not vaccination helped you avoid hospitalization, they would have had to compare, just get rid of the delta and the alpha, clump them together, and just look at vaccinated versus unvaccinated, which they didn't do in this paper. And I wish they would have done that, because that would have been an interesting piece of information to know too. So it's unclear from this paper whether vaccination helps you get admitted to the hospital or not, helps you from getting admitted to the hospital. But what we do know is vaccination makes no difference between alpha and delta, according to the way that they did their analysis. Okay, so I don't know if this format of the video was interesting to you guys. It's a little bit slow because there's a lot of dead time because I'm reading through it for the first time. And so a lot of it is just me reading the paper. Let me know if you like the kind of unfiltered take on the paper where I don't read it before and I just go through it, or if you prefer that I would have read through the paper and just kind of summarize the highlights of it beforehand. All right, thanks for watching.